Okay, so this is Sunday, week 8. We're going to go ahead and go over some of the rules and laws of exponents. So I want you to take a look at number 1, adding and subtracting monomials. So mono means one term, like 2x or 4 or negative 4x cubed. Do you see that? Okay. Binomial means two terms. Okay. For example, 3x squared plus 4. Do you see that? What's in between them is a plus or minus that separates them. Okay. Trinomial means three terms, right? Like negative 4y squared minus 4y minus 4. That's three terms, right? Anything after this that's more than three terms is called polynomials. Okay, so that's 4 or more terms. An example of that could be 3m cubed minus 2m squared plus 4m minus 1. Minus 5. There we go. Does that make sense? Okay. Okay. Take a look at the first example. With the first example, you see how this is the first term, 2a to the m power? That's one term. 3a to the m power, that's another term. Both of these terms are the same because they both have the same exponent in the base. The base is the a. Do you see that? The m is the exponent. So with this one, the a here is the base. You want to label that. N is the exponent. Okay? You can always combine them if they have the same base and same exponent. Okay? So because the a is the same and the m is the same, so the base is the same and the exponent is the same, you can then add the coefficient, which is 2 and 3, which gives you 5a to the m power, right? Combine like terms. Do not change common variables or exponents. So what it means, do not change common variables and exponent, is that you see how the a is exactly the same for the answer? Yeah. And the base a did not change. The only thing that changes is the coefficient because you're combining like terms. Okay? So for this one, x squared, y, they're the same, right? So you look at this, 9 minus 10 is a negative 1 x squared y. That is your answer. Okay. Same thing with the next one. W, base, correct? Exponent 1, exponent 1. 8 plus 6 is 14W. Do you remember this from last year? A little bit, okay. Okay. Product of power. If you have the same base and they're multiplied, you can add the exponent together. Okay? When multiplying, keep the base and add the exponent. As in the base has no changes. Yeah. So here you add them and the 9. Here you add the 2 and the 4 together. Yeah. The 3 and the 5 together. You kind of remember this? A little bit. A little bit? Okay. Function and power. We use the same base. You always move the smaller base up or down. But when you move it up or down, you have to change the signs. Okay? When dividing, move the base and subtract the exponent. Take a look at this one. Same base, x, correct? Which one's smaller? So you move it up. Because if you move the smaller number up, you always end up with a positive number, right? So then what you have here is x, 8 minus 3, which is x to the 5th power. Okay? Here, you try this one. You see where I'm putting the arrows right there? Yeah. Negative exponents. We have a negative exponent, we don't know negative exponent, okay? So to make it a positive, you just move it up or down the fraction bar. You see how this is over 1? When you move it down here, 1 comes up here, and you have a to the n. Positive, right? Make a negative exponent positive by moving it across a fraction bar, okay? So if you have, like, let's say ax to the negative 2, that is going to be 1 over x squared, right? Or if you have 1 over a to the negative 4, if you move it up, it's just positive a to the 4th. Do you see the difference? When you move it down, you have to put a 1 on top. But when you move it from down up, you don't need to put a 1. Okay? Yeah. All right, so m to the negative 10. This is over a 1. You move it down. It's equal to 1 over m to the positive 10. And if you take a look at the second one right here, with this one, do you see how the A is positive? I don't need to move the A. The only thing I always need to move are the ones that are not positive, like negative, like B negative 2. Do you see that? C negative 3. Everything else stays exactly the same. So the D stays down here. You don't move the D because it's positive, right? So when I move the B down, it's a B positive 2. When I move the C up, it's a C to the positive 3. You good?
Can I go ask him?
Yeah, let's go ahead. Yep. Let's take a look at the next one. 0 exponent. Anything to the raise the 0 power is not 0, it is 1. It's not 0. A lot of people will say it's 0. That's the biggest mistake. Okay. So 9 to the 0 power, 1. R to the 0 power, 1. It's just 1. Okay. Now, do you want to go over something else? Or like pick another one that you would like to review and we can go over it together. Well, pick another. There's plenty in there. Yeah, pick one. All right, let's go ahead and practice a little bit. I'll write down the answers. You practice on your own, okay? So go ahead and do that. You work on your own, and when you're ready to check your answer with me, okay?
Mhm. Like for the first row, or
Yeah. All right, so A doesn't change, right? Because there's a 1 right there, correct? There's nothing dividing it. So when I move the 1 over there, it's a -1. Do you see that? And then I move the 2 over there, so it's a -2. Okay. All right. But yeah, just okay. Another way of remembering this, Grayson, is when you have x, like for example, x to the third over x. When you move it up there, it's a -1, so it's x squared, correct? The reason why it is x squared. Okay, what is happening? Okay, here we go. Is because we have x to the third over x. What this means is that I have 1, 2, 3 x's on top, right? Of 1 x down here. Do you see how this x and this x cancel? So how many x's on top do you have?
2.
So it's x squared, not 2x, but x squared. Does that make sense? That's why when you subtract them, you lose one of them, or however many you have. Does that make sense though? Okay. All right, so then continue on. So with this one, with the power of a quotient property, you just distribute in. So it's a to the m over b to the m. So when you distribute this here, do you see how the parenthesis covers the top and bottom? Yeah, so that's why you do it to top and bottom. So practice with this, try it on your own. Okay, so going into this page, you can go ahead and pick any questions after you do 7, 8, and 9, okay? So pick 2 more questions, so 5 total, and then we'll go over it. But your answer's on the right side. Do you see that though? Okay, so for number 7, do you see how there's a negative exponent right there? And there's a negative exponent right there. But the thing about it is, like, you have a -4 here, but that's okay. That's not a negative exponent. So -4 is totally fine. Okay. So looking at the x and x, right? Because they both have the same base. Between -3 and -4, which one's the smaller number? Yes, I'm gonna move it up. Okay. So when I move it up, I'm gonna have a -4x, -3 plus 4. Do you see that? Do you see that? Because when I move it up, it becomes a +4, correct? Okay. So then that part right here becomes x to the 1 power. Do you see that? And hold on, don't do anything yet. I want you to watch what I'm doing. And then do you see here you have a y to the 1 power, y to the 0 power? Y to the 0 power becomes just 1, right? Y to the 1 power is positive, so you don't need to change anything. So you just have 2 times 1. Do you see that on the bottom? So your answer is -4 xy over 2. But then you can reduce this part to a -2 xy, and that is your answer for number 7. Okay. So now, if you look at this, that answer is right here. So that's 7. Do you see that?
Mhm.
Okay. Now you try 8 and 9 and see where you get to. Okay.
Two of the question I chose were 12 and 2.
12 and 2. Okay. For number 12, you divide 10 divided by 5, which is 2. Move the 2 up, so x to the third, correct?
Yes.
So that's number 12. And number 2. 2 times 3 is 6, right? -3 plus 2. Do you see that?
Yeah.
But then I don't want a -1 exponent, so I bring it down, so it's x. Do you see that?
Mhm.
So that should be this one right here. Did you get that one right there?
Close.
Close. Okay. But do you understand the mistake you made? Okay. So I want you to take that and actually I'm just gonna give you the answers for the rest of these right here. So for number 1, 2x. Do you see that?
Mhm.
For 1. Number 3 is easy, it's just 1.
Yeah.
Right? Number 4, 1 out of 3, x to the 4th power. Okay. Number 5, 8. Make sure you put up 3 goes down, so it's x squared. Y goes up, so it's y to the 3rd. So don't write the answer down. I want you to try this on your own, okay? But I'm just doing this so that way I don't have to keep doing this. This part gives you 1, correct?
Or can I just write the answer down?
Yeah, that's fine. Well, you see the answers right here on the side, just put the numbers on the side. Right here. Yeah, that way you can still do the work on your own. This is a 1/4. X to the 5th does not move because it's already positive. Y to the 11th. This is a 6. And the last one's number 11, -6, x to the 7th. Did we just not do this one? Number 3? Oh, no, here we go. That part cancels. It's just 3. This is 10. Does that make sense?
Yeah.
Okay. So this is where you're going to go into. So I just suggest you start practicing with them, okay? All right, so I'm going to staple this. And I'm going to have you, this should be the first one here. Where's your math notebook? Go get your math notebook, please. And then we'll put this in there.